情，到底什么价？哥哥多少钱才能够把你拿下？我爱你，你爱我，同时爱着他，这种三角关系让哥好尴尬。你说你要走，哥的眼泪哗啦啦。
Scene creation. You can see a machine on the center of the screen. There are 6 axes, J1 to J6, which represent x-axis, y-axis, and z-axis, and the ABC axis. As the J1 x-axis move on the top of the foundation, the y and the z will follow. As the y-axis move, the z will follow, but the x still stay there. As the z move downwards, the x-axis and the y-axis will not move. Only the z move, because there is a hierarchy structure. The parent move, the children will follow, but the children move, the parent will still stay there. As we design the machine from the CAD system, suppose it is a SolidWorks. After creation the machine, you have to separate the machine depends on the movements. That means individual movements. The X, Y, Z, A, B, C. And one biggest part is the foundation. We have to export each part into IGS file. We translate the IGS file of the structure of the geometry model to X file, because the 3D acceleration graphing card can use API function to input the S file into graphic card and doing dynamic drawing. Now let me introduce the polychance, which can do the translation from the IGS file into X file. We use import 3D geometry function and pick IGS ASCII file function to import the foundation from Genfa files. The foundation is m.igs.
你是
Haha, what a big file. The foundation is displayed on the screen. We have to export, by means export 3D geometry into the rest file. We export the positive part of the geometry. We call it M1A, and then we export by means of 3D geometry into the rest file. We pick reverse orientation of all polygons and normal, and pick flip polygon normals. Okay. The export file, we name it M1B. So the positive and the negative parts of the foundation are exported into X file. Then we have to combine the positive parts and the negative parts of the foundation to create the foundation's X file. We reset scene. We don't save the data. Then we import 3D geometry from the rest file, from gem file. The positive part is M1A, and import 3D geometry from the rest file, M1B, the negative part. The M1A and M1B, we have to combine it and to export the total the rest file. We choose the positive parts, name it M1. Okay, the foundation M1 is finished. And then we can import 3D geometry from IGS file. The one on the top of the foundation is x.iges. It takes too long to translate the files. Depends on the size of the IGS, depends on the size of the model. So thereafter, we just introduce. We don't do it individually. The same, the X file in, then we export the rest file, the positive parts, as S1A. Then we create the negative parts S1B, and then load X1A and load S1B into polychans and export the combination, then the S1. And then delete the buffer of polychans. Then import the y.igs and export the rest y1a positive parts of the y structure, and the y1b and then load y1a and y1b and combine it to export y1. The z is the same. The z.igs can be imported by IGS ASCII file and export the positive parts z1a and export the negative parts z1b and reload z1a and z1b to create z1, the compilation of the z structure. The rest a.igs the same to create a1a and a1b and combine it and a1. The b.igs the same create b1a and b1b and combine it to export b1. The c the same create c1a and c1b and combine it as c1. The cc.igs is the fan, is the window. We create cc1a and cc1b and combine it and cc1. The m1, x1, y1, z1, a1, b1, c1, cc1 created. We have to move them into data file. We go back to our system. As those data in, we can see individually M1 is the foundation. X1 is this one. Y1 is this part. Z1 look like this. And the C1 turn part. And the A1 this one. And the B1 this parts. And the CC1 is the window. You see the window. The window up as water jet to prevent the water will flood into the machine here. As the turning table movement, the window will downward to the bottom. Otherwise, the correction is avoidable. After this X file created, before we use sync input, we have to prepare a CS file, Excel CS file. This CS file is divided by 3 parts. The first important part is the sync X file. The second important of the CS file is the hierarchy structure. That means to define which object is parent, which object is children. The third part of the CSV file is the relationship of our control car. The relationship between control parts and the machine. We use 6-axis motion control car, in which names the 6-axis is named X, Y, Z, A, B, C, just the same as our machine, X, Y, Z, A, B, C. Now we see the actual demonstrations of the CSV file. The first part, the S file in here, you can see the M1X, X1S, Y1, Z1, C1, B1, A1, and C1. The S file triangle part is what we call it mesh. The mesh 0, the object 1, object 0. The mesh 1, object 1 is simple and better for remember. One mesh can be used by several objects. We don't need so complicated structure, so it's better 0 mesh, 0 object. Mesh 1 and object 1. Mesh 2, object 2. 1, 2, 1. It's better to create the CS file. The column shown in here is M1X to be seen. The 0 means this is hidden. The tool, the show is 1, is you can see the tool. In here is 0. That means X AR 10 point X could not be seen on our system in the first moment. Okay, let's see the definitions. The basement M1, we call the object 0. The X1, we call the object 1. The object 1, X1, attached to 0. That means attached to M1 foundation. The Y1, we name it object 2, attached to object 1. That means the Y1 is on the top of S1. That means the x-axis is the parent of y-axis. As the x-axis moves, the y structure will follow. As y structure moves, the parent x will not move. The z structures, we name it object 3, is attached to 2. Is attached to 2 is y structure. The C1 structure, we name it object 4. Object 4 has no relationship with x, y, z, which is independent parts. Attached to 0, attached to the foundation. The B structure and the A structures is on the top of C structure. The B1, we name it object 5, on the top of object 4. That means on the top of C structure. The A1 structure, we name it object 6. It's on the top of object 4, the C structure as well. The C1 is the window. We name it object 7, which is independent object attached to 0, attached to the foundation. The rest, objects A to object 13, is a dummy X file, which used especially for the limitations of X, Y, Z, A, B, C. The tool, we name it object 14, is on the top of object 3. Object 3 is Z structure. At the tip of the tool, there is a RGB arrows. That means X, Y, Z arrows, to show the tip of the tool and to show the TCP points. So right now we have introduced the X file in the CSV file, and the parent and the children's relationship by means of the attached to column. The third part of CSV file is very important to show the relationship of our machine and the motion control car. We say we use 6-axis motion control car. The 6-axis motion car is defined by X, Y, Z, A, B, C. In here, 1 is X, 2 is Y, 3 is X, A, B, C. We use the numerical to represent the ASCII character. Okay, let me introduce the third part, the most important third part. For X structures, in this column, translate, that means translation, rotation. The X structures in this column, we can see 1 in here. The basement in here is 0. 0 means these parts will never move. It's a steady part. The 1 translation rotation, it means it's a translation movements, translative movements. He moves along one single vector, one single directions, straightly. In here you can see XYZ is 1. It's a Cartesian straight line movement structure. The CBA is in here is 2. 2 means rotation structure. Okay, let me introduce the X structure. Translate. In here, axis 1 means we use 6-axis motion control car. The first axis to control the X structure. Which is direction N1, 1, N2, 0, N3, 0. 1, 0, 0 means the X structure move X directions. The movement structure in these 3 columns has no influence. We just feed in 0 only. Now introduce the Y structures, Y1 dot X. Transrotate is 1. It's translative movements. In here, axis, we use 2. Use Y-axis to control the Y parts. Which direction N1, 0, N2, 1, N3, 0. That means you move Y direction. The S pilot, Y pivot, Z pivot, we feel 0 only. The Z structures translate rotation is 1. It's straight line movements. We use the third axis to control it. The movement direction is N1, 0, N2, 0, N3, 1. That means Y direction, Z direction movements. After this, we introduce the C structures, which is 2. That means rotation parts. We use 6 axes to control the C structure. The rotation direction is N1, 0, N2, 0, N3, 1. That means Z direction is its rounding axis around. Turn around the Z axis, the pivot point is 0.005 minus 1004.5. This is a SY coordinate. As it around the Z axis, the Z pivot can be fitting anything. We use 0 instead. The B structure is rotation parts as well. Use the 5th axis to control it. Its turning direction is Y directions because N2 is 1. The pivot point X is 0.005. The Z is Z pivot point coordinate is minus 66.65. Because it's Y directions, the Y point column can be filled in anything. We used 0 instead. The X structure, it is a 2, a rotation parts. We use the 4th axis to control it. The turning axis is Y axis because N2 is 1. The rest is 0. The pivot point X is 0.005. The Z pivot coordinate is minus 66.65. The Y column will still fit in 0. The most important I have to introduce is the CC. That means the window. The window in here you can see translate is 0, which is fixed parts. It's static parts controlled by nothing. That means it is not controlled by motion control car. Actually, it is controlled by PLC by means of a vacuum piston. There are 2 vacuum pistons located vertically. You can push and pull the window upward and downward. Push down to turn the table C around. Pull up to fan the water jet flooding the machine. In here, we have to emphasize the continuous currents. Here you can see a 6. Continuous current is 6. That means it's the 6 structure, 6 machine structures. Suppose 1 is robot, traditional 6-axis robot. The 6th structure is this size machine. We call it robot as well. Okay, let's go back to the system. New to delete all the contents of the memory. Sing input to get a file. We just sing, which name cache 30. After CS file import by means of a sing input, the first step is to check if the CS file, CSV file is correct or not. Before we do anything, we do next script input or action teaching. We have to make sure all the access is correct. How to make sure all the access is correct? That means how to check these things. We can use the teach mode. We push J1 plus to see the x-axis is moving in a positive direction or not, and the rest children's x, the y and the z will follow or not. You can see it's correct. The minus direction the same. The x-axis movement is correct. Then we check the y-axis. It's J2 minus. This is y minus direction. It is correct. J2 plus It is correct. The Z component follows. The X component still stand still there. The Z structure downwards. The Z structure upwards. The X and the Y structures stay still. We know the 6 is C structure. Positive movements turning around. Negative turning around is correct. The B and the A structure will follow because they are children. The A structure turning. The C structures still stay there. The B structure turning. The A, C will not move. So we say the CSV file is correct. Reset. Go back to orientation. Now scene creation is fully introduced. The end of the demonstration.